we continue to test this Makita for the temperature profile and power consumption. We did already 3 tests. 2 tests from the AC/DC adapter in the fridge and freezer mode, and 1 test from the DC power from the battery in the fridge mode. This test will be from the DC, from the battery in the freezer mode. All links in the description below, but I will anyway briefly explain you what are we testing. So basically 2 things that most people concerned about because of the nature of use of the portable fridges. So 2 things: power consumption and the temperature. For the temperature, I have here the sensor in this tool and iSocket specific sensor connected into iSocket, because this allows me to collect temperature profile, so the temperature of every minute temperature, and then review in details these things through this feature, iSocket historical temperature data. Please focus. Okay, it doesn't matter. So, and that is about the temperature. Yeah, actually I won't dedicate a lot of time to the temperature profile in this video, because it has been reviewed multiple times in previous videos, including when we tested Makita from AC/DC adapter. Actually, you have these 2 profiles here for the freezer and for the fridge mode. So just watch this video. There will be no difference when I power this from the battery. So let's say I explained about the temperature. If not in this video, in the next one. But I will continue use this sensor to monitoring the temperature there. So what about the consumption? Yeah, I power this from the battery. I can research the current with this current probe and oscilloscope, but I don't do this also in this video, because it was in the previous one. There will be no difference. So after all, the only difference will be how much amperes hours we will drain from this battery in the freezer mode for a single day. So, and that we test by powering this one day from the battery, and then we charge it. This Victron Charger in the application allows us to see how much amperes per hour we added to the battery. This we will see. We compare with the fridge mode, we compare with the Chinese one. And when we power it, we do this through the iSocket, and iSocket calculate how much energy we drained from the AC power, from mains. So, and this allows us to see on the iSocket energy meter here how much energy we consumed. Here is the statistic from previous experiments. This way we know how much it cost us to charge this battery. So wonderful, right? I just plug, we wait till tomorrow, I unplug, then I charge, and we see the statistic. I hope this time it will be short video. Guys, I promised this video to be short, but no, it's as always, because I found out quite interesting stuff about the current, yeah, sine wave of the current. You have seen then when I connected, it was the mean was at about 4 volts. It actually corresponds to previous experiments. If you see in the previous video, we also see it about 4 amperes. So currently I have 10 millivolts per ampere, and here we set 10 millivolts, the middle is 5, so we see about 6 mean. And actually I just proved this with that cheap current clamp that also shows this 6 amperes. More or less should be okay to see it here, more or less, because when I disconnect it shows something too. Yeah, so let's just try to reverse it. -4 and 4. Yeah, that's quite interesting stuff. Okay, let's check it by the negative. 4 and 5, and reverse 6 and 1. Yeah. Well, guys, that is interesting stuff, because just a few seconds ago you have seen this to be lower and then it rised. If some of you knows things about compressors, then let me know in comments, because my only suggestion is that it has some kind of smart compressor with power regulation. So because when we been using this in the fridge mode, and when it start working it's about 4 amperes, but now because we set the freezer mode, it probably understand that need to provide more power. Because when I was testing this Chinese one, so how it works, it doesn't depend, the temperature settings doesn't affect the operation. So the compressor just start and stop, and the temperature is about how long the compressor is running. Running more, it will cold till minus. If you don't want minus, you should stop the compressor early. But here it looks like in the fridge mode it just apply less power. So something probably more smart. If someone knows, or probably someone who opened this and repaired, let me know in comments. I'm really interested about this. So, but now we see at almost rated power, because it is rated, I don't remember if I told this, 90 watts and 7 amperes. Yeah, and we see almost this 7 amperes. Well, it's in wave current for the compressor, but we do see this. That's quite interesting stuff, at least to me. So now I hope, yeah, I will get back to you after one or couple days about how much we add charging, or probably later when we close to minus I will check these measurements again, and let's see what we see here. Look, minus 18, I come here later, and yeah, we see the drop in the current. That's quite interesting. Well, I come a little bit later because it was switched off when I explained to you. So, and now we see here is E5, it's the center, so we see about 6, but actually I wanted to check with this clamp meter also, 5.3, yeah, about 6. And also what is the voltage drop when it is operating 1244. Yeah, guys, something smart is there. It looks like that. Otherwise, how it can change the current? So it's not just about start, stop. Something else there. Well, one day, almost. Yeah, so we see the current about probably 5 here. 4.3 according to this one, and the batteries 11 and 6, 5, something like that. Yeah, so now I switch it off and place this battery for charging through iSocket, and we calculate energy we need to charge this battery from mains network. Well, guys, I decided not to disconnect it yet, because I noticed that it started again at minus 15, and now it stopped again. And I recalled one situation, because I already used it one time in a cottage from this battery, and I noticed that the behavior after one day of the compressor is different. it switch on and off more often. And now guys, also when I look into the temperature profile, I notice some problems there. So you remember we have seen nice freezer profile from the AC/DC adapter, then fridge profile from the AC/DC adapter, and this is that is, yeah, actually it was from the battery also, and that is from the battery in the freezer mode. I see some issues there. If I look for today only, it's clear. Oh, by the way, now it started. Can you hear it? Yeah? So, I see some issues. And guys, I understand that there is a kind of protection there in the compressor, and this low battery is already bad for the compressor, so it's switch on off more often, probably off more often. Yeah, it's trying to get something from the battery, but it doesn't work. And look how nicely I can see this on the temperature profile. So it is actually the way to understand that something is going on wrong. In that case, not with the compressor, but with the battery. Yeah, so if we look for last 3 hours, yeah, I like it. Yeah, look, we see definitely something has happened. Yeah, but we know what has happened. Yeah, 1 day absolutely maximum when outdoor is about 20 to power from this battery. So yeah, we know it now. Whoa. So via iSocket I started this charger. So we see this voltage now. That is the first time when I have seen test mode on this charger for so long time. And I also reset energy meter so that we start from that point, counting how much energy we drain from mains to charge this battery. We have all previous statistics here, so we want to compare statistic, please. Yeah, okay. We have all that statistic here about how much power we use when we power this from AC/DC adapter, how much it costs to us. So we will compare which mode is more beneficial, let's say. Well guys, it's charged, yeah? So it is not in the float, it is in the storage mode. Yeah, we can see this in the up. Let's also check the voltage. 1352, yeah, exactly what we see here. Yeah, and now the most interesting, wow, a lot, again a lot, yeah. So guys, we added, so it took 9 hours, 53 amperes hours. I think it is bulk 32 plus, yeah, plus absorption. It doesn't count here in the charge how many we added in the float mode. So float mode consider it as extra in this up. So they consider that, and of course not storage, they consider that when absorption is ended then it's charged. Well, maybe it's okay. So basically 53 amperes hours. So it's half of that battery was drained from for the freezer mode. So the battery is 12 volts 100 Ah, so it means 1 and 2 kilowatts power. So, and we spent half of this. Well, we can multiply 53 to 12. I need my calculator. couldn't find right now because I wanted just to show you it's easy. I will do this soon. So 53 amperes hours we added to this battery. Let's briefly compare how it was with the Chinese one. Actually, it was the same. It was that one. Yeah. So when we use this in the freezer mode, it's the same. So the same drain for the battery. When we use this in the fridge mode, it was just that small amount. I don't know how was it, but it was just that one. You can watch the previous video. But when we use Chinese in the fridge mode, it was this one, quarter of the battery. Guys, I think I will do compare of all values later after I finish this test. It is going to be in the next video. Now I power from the native batteries. So if you are subscribed, you will get notifications when this video comes out. Otherwise, please subscribe. So, and there I think I will compare all results sitting over my computer because it's not so convenient here. Okay, so 53, remember, because now we are going to see how much iSocket shows us energy that we spent to charge this battery. Okay guys, let's try to do some math. 12 multiplied 33, so we have that amount of watts we added to the battery. Yeah, well, fine. And this is half of the battery. Yeah, so yeah, and we also reset statistic, so we have now everything in the iSocket energy meter statistic. So, and we can see that to charge this battery we used 800 watts. Yeah, it sounds logical, right? To add this amount of DC, let's say, to the battery, we need that amount of it sounds non-professional to say that amount of IC, but you got the point. Yeah, so we can now figure out the efficiency of this. I will do this in the comments. Yeah, so maybe about 90%, something like that, I don't know. Yeah, but let's also compare these things. So when we powered this from the AC/DC adapter directly in the freezer mode, we spent half kilowatt. Yeah, and when we power this from the battery and then charge the battery, 0.8. Logical or not, I don't know, but it's cheaper to run it from AC/DC adapter. When this experiment was in the fridge mode, it was quite opposite, and I don't know why. So from AC/DC adapter, 158 watts, and from the battery and then charge the battery, 128 less. So why do you need this data? So it's up to you. I just provide numbers. You probably evaluating as me a solar project, and you want to know what is the right way for you. So what kind of equipment you have, where to put AC/DC adapter, where you don't need, you need to sacrifice a lot of if. So it's quite difficult to figure out the best way. Yeah, it's not that straightforward like some people think. Like if you all have all DC, then go with DC. If you have all AC, then go with micro inverters. No, it's not that straightforward, and it's up to you to decide. I just give you the numbers. Yeah, so wonderful. I think we tested everything about the temperature. I don't remember if I mentioned here, but in the previous video we had a lot of information. We only need to test this in the fridge and freezer mode from the native Makita batteries, and that's what I'm doing right now. So it is going to be in the next video. Subscribe to see it. Remember to like it, give your smart comments. See you next time. Bye.